Hello everyone, my name is Kesu Wang, a master student at Nanjing University. Today I will report our paper, Unified Abstract Syntax Tree Representation Learning for Cross-Language Program Classification. Let's start with the background. Cross-language program classification refers to how programs written in different programming languages can be classified by their functions according to the structure and the semantics of their codes, and it can be regarded as a high-level abstraction of code, laying a foundation for various tasks related to source code comprehension, such as code clone detection, code reuse, etc. As shown in this figure, our purpose is to identify the algorithm implemented in these different programming languages at the same class, for example, the sorting algorithm. However, there are two major challenges in classifying cross-language programs. The first challenge is that it's hard to capture code semantics efficiently and accurately. The second challenge is that different programming languages have specific coding rules which make programming languages look different. To address those problems mentioned above, we proposed a neural network called Unified Abstract Syntax Tree, UAXT for short. As illustrated in Figure 1, firstly, we take different programming source codes as input, and then pass them into ASTs. Afterward, we use those ASTs to build our unified vocabulary. Then we perform path embedding and graph embedding using the unified vocabulary on ASTs. After that, those embedded vectors are fed into different subnetworks to capture code features respectively. Finally, we fuse separate learned features and conduct the classification task. That's the whole process. Next, let's focus on key parts of our model. For code semantics extraction, there are two subnetworks. One is the sequence-based AST network. The obtained path sequence through pre-order traversal can be regarded as a flattened presentation of the AST, and self-attention and by-LSTM could extract internal and contextual features respectively. The other is graph-based AST network. It aggregates information from neighbor nodes to capture local features. The fusion of global features and local features can be regarded as the code semantics features, which could solve the challenge 1. By parsing different programming languages, it is found that there are some differences in the node names of ASTs. In order to reduce the differences in node names between different languages, we proposed a mechanism called Unified Vocabulary, which is mainly used to normalize AST node names in different languages. Specifically, we use unit to replace program translation unit module, which will reduce the difference between different coding languages. Then it could solve the challenge too. As for experimental design, we use two datasets, one of which is collected by Bowie and contains 10 categories, and the other is a dataset that we collected from LeetCode and contains 15 categories. We choose CodeBird and InferCode as our baseline. Both baseline can deal with the cross-language code learning. And we choose common evaluation indicators, precision, recall, F1 score, accuracy, to evaluate the model performance. As for model performance, we compare UAST with the baselines mentioned before, and the results of the comparative experiments show that our model significantly outperforms other baselines. In order to explore the function of the unified vocabulary and the fusion mechanism, we conduct the ablation experiments. The results show that the unified vocabulary and the unified AST feature fusion do improve model performance to a certain extent.
To summarize the contribution of our paper, we propose a framework called UAST for cross-language program classification. Our model contains two subnetworks, SAST and GAST, where SAST is used to extract the global features contained in the AST path sequence. GAST is used to capture the local features of the AST. In addition, the unified vocabulary mechanism we proposed can reduce the differences between different program languages. The comparative experiments on the public dataset and our collected dataset both show that our model performs better than other state-of-the-art baselines by a significant margin, and can better distinguish between different programs.
That's the report of our paper. Thank you for listening.